Hello, today we'll be solving a physics problem. This question asks, a billiard ball collides elastically with its identical stationary one. Use the fact that mv2 over 2 may be written as mv times v over 2 to show that the angle between the resulting trajectories is 90 degrees. Let's get started. So what I have here is a small demonstration of achieving a 90-degree angle using the billiard ball. These two balls, even though are small, they have the same mass, and I will attempt to hit them to form a 90-degree angle. So imagine here we have the cue ball on the left side and hits the other cue ball, and both of the trajectories is 90 degrees. Well, let's first assume that these cue balls are all the same mass. They weigh the same. First, we want to find the equation for the momentum in the x direction and the y direction, and also the kinetic energy. The kinetic energy is energy an object possesses due to its motion. So let's get started. So here we have theta. Theta is the unknown measure of the angle, and momentum is the mass of an object along with its velocity. And the momentum formula goes like this. P equals m times v, where m is the mass and v is the velocity. So in this case, we have the billiard balls will have a mass of 1, the first one, and the second billiard ball will have a mass m2. And velocity 1 is for the first ball, and velocity 2 is for the mass 2 ball. Hence, the drawing in the figure has m1, m2, v1f, and v2f for final velocity already. So first, for the momentum in the x direction, we'll draw it. Here, you have the ball going in the x direction, and this ball as well going in the x direction. Here we have velocity 2 final for the x direction, and here we have velocity 1 final in the x direction. So we could write the equation as m1 v1 initial equals m1 v1 final cos theta plus mass 2 velocity 2 final of the ball, second ball, cosine theta. And now we're going to draw the momentum in the right direction. So let's draw it. So y is going up and down. So this part is going up because it's the top part, and this part is going down because it's in the negative axis, negative direction. So we could write it as v2 velocity y, final velocity y, and v1 final velocity y. So it's v1 this part, this side, and this top part is v2. And the top part right here, it would be, the top part would be m2 v2 final sine theta. And so this part right here would be m1 v1 final sine theta. So writing it together, we're going to have m2 v2 final sine theta minus m1 v1 final sine theta. So you might notice that I put the zero value here. The reason why it's a zero value is because this is before there's any movement. So it's before mass 1 ball hits the mass 2 ball. And so this would be our second equation. This is our first one. So there's our first equation, second equation. And so for the equation for kinetic energy, since a ball will move when energy is applied, as you know, it goes like this. So let me write right here. So 1/2 mass 1 and v1 initial squared is equal to 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. So this is our third equation. So let me just write that again. Our third equation. I'm gonna rewrite this again. So 1/2 m1 v1 initial squared is equal to 1/2 m1 v1 final squared plus 1/2 m2 v2 final squared. So this part here is the ball before it hits. This here is for the ball at the bottom, which is right here, and this for the ball at the top, which is right here. And so now we have our three equations. So now that we have our three equations, which is right here, equation 1, equation 2, equation 3, we can simplify it. So since all balls are the same mass and it doesn't matter, we could just cancel out the m1s. So let's do that. So this cancel out, 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 cancel out. So let me just erase them just to make it easier. You'll cancel them out. So cancel out this one, cancel out this one, cancel out this one, cancel out this one, cancel out that one, cancel out that one, this one too, and this one too. So the reason why we're canceling them out is because the mass of the balls are all equal. So there's really no need to be doing any extra calculations. And this makes it easier for us to understand the problem as well. So this is our more simplified version of the equations that we're working with now. So now looking at our three Paul's equations, we notice that this one is only one that's squared. But these equation 1 and equation 2 are not squared, so what we're going to have to do is square these two equations as well. So let me clean this up. Oops. All right. So let me write the equation 1 squared. So it'll be v1 initial squared equal to v1 final squared cosine squared theta plus v2 final squared cosine squared theta plus 2v initial squared plus v2 final and cosine theta cosine theta. And so for equation 2, it'll be 0 is equal to v2 final squared sine squared theta plus v initial squared sine squared theta minus 2v initial times v2 final sine theta. So what we're going to do now is add them together. So it's going to take a while. I'm going to have to erase this just to make more space for us. So we're going to have to add equation 1 and equation 2 together. Oops. Oh boy. We're going to get this v1 initial squared is equal to v1 final squared. And then we have sine squared theta plus cosine squared theta plus v2 final squared, and then cosine squared theta plus sine squared theta plus 2 v1 final, and then v2 final. Then we have cosine theta minus sine theta. And so, as we can see, we have sine squared theta plus cosine squared theta, cosine squared theta plus sine squared theta. As you know, the Pythagorean trigonometric identities, sine squared x plus cosine squared x is equal to 1. And here we have, by the sum difference identity, it should be cosine theta minus sine theta is equal to cosine theta plus theta. So now cleaning this up, to make it simple, this is equal to 1, and cosine theta plus theta. So we're going to have to rewrite this to make it more easier to understand. So v1 initial squared is equal to v1 final squared plus v2 final squared plus 2 v1 final and v2 final cosine theta plus theta. So you guys might notice that these terms are all the same, and we're left with only these terms sticking out. So we're gonna have to erase these that stick out just to make it easier. So our equation now is 0. It's no longer equation 3. Equation now becomes 0 is equal to 2 v1 final and v2 final cosine theta plus theta. And so v2 final is our ball at the top, and v1 final is a cue ball at the bottom. And so it comes down to basically cosine theta. And so the equation will be 0 is equal to cosine theta. And so if we were to look at a trigonometric unit circle, here it is, for instance. This part would be cosine and the one would be sine. So we see cosine 0 is equal to pi over 2 or 90 degrees. And voila, that's our answer. That's how we know that cosine 0 is 90 degrees. So after solving our equation, we found that cosine theta is equal to 0, which is also pi over 2, which is equal to 90 degrees as well. So here I have my right angle stick to measure 90 degree angle. And we saw that the cue ball was hit in the right direction with my force, and then it splattered out. So let's see if the trajectory is 90 degrees, a right angle. And we can see that it is a 90 degree angle. So this solves our problem. When you hit two balls of the same mass, then the trajectories will be 90 degrees. So thank you, and hope you enjoy.